Sorry, we're just talking about looping today, and I got the PowerPoint up, and we're just talking a little bit about loops before we hop into the worksheet. So if we end up not ever turning this condition to false, that's an infinite loop. It's going to freeze your computer. At home, you can force quit out of Unity, but here we can't force quit out of Unity. It's just the way that we have the computer set up. At least you can force quit out. Old type computers, if you did while loops, you would have to actually reboot the computer. So this is super important. And so anytime you're working with looping in this class, you need to make sure that you don't accidentally have a while loop. Like doubly make sure that something is going to eventually turn it to false, because you might not necessarily get an error with this. Like it's not like an error where you get like the red squiggles. I think every once in a while I've seen it catch it, but this would be considered more of like a runtime error, because it's not going to get caught until we hit that while loop during runtime. So this is a little bit better of an example for doing a while loop that will quit. And it pretty much is also the answer to the first question on the pop quiz of creating a loop. The only difference is I asked you to use a integer called counter and go up to 10. So this is a good example of just a basic while loop that has a condition that will eventually end the loop. So while I is less than 3, do this code. So at first it's 0, so it's going to go into here. It's going to say print this. So it's going to say loop is equal to 0. It's going to raise that I by 1. This is the increment operator, and then it's going to go back around and test it again. I is now equal to 1. It's still less than 3, so it's going to print out loop is equal to 1. Raise it again, so now we're up to 2. And it's going to go still good. Raise to 3. 3 is not less than 3. So we would only ever get it saying loop is equal to 0, loop is equal to 1, loop is equal to 2. So this is a really great basic example of setting up a while loop with a counter. Yes, question?
So theoretically, like, could we use that would make like a timer or something?
Yes and no. You don't really want to use while loops in Unity for anything that you want to have happen in real time. So the examples that we're going to do, like in the lab and in the project this week, it's stuff that's going to occur when you hit the start button. Like the lab is going to be setting up, like you're going to click a button and it's going to create cubes on the board. The reason is because when you run a while loop, kind of, the whole reason it locks up if you have an infinite loop is it executes the while loop and it locks up Unity until that while loop is completed. So normally that's not much of a problem. Like if it only needs to execute 10 times, that happens in less than a second. So you never actually see it like freeze up or anything. But while this while loop is going, Unity is frozen until it's waiting for that thing to be done. So it wouldn't be a necessarily good thing with a timer. I believe for a timer, you'd probably want to do stuff with like the update, since update is clicked like once every so often. And we actually do a timer in a couple weeks as part of, I think it's a lab that we're going to actually code out a timer.
I know, I'm asking because I need to do a timer for SGD design.
Yeah, there's a lot of timer code out there that works really well using, I think, time.delta time or time.time, and you multiply it by something. And I think you do it in the update, or I think you need to do it in fixed update in order for it to work correctly.
Can I see you after class for that then?
Maybe, because I know part of design is you kind of, if you have code that's not working, I can help you, but I can't give you that code. So the difference between a while loop and a do while loop. Obviously structurally, where you say do at the top, you have your code, and then at the end you have your condition. The difference is with a while loop, it's possible that this condition is false to start with. Like if you started off in this one, I at 10, I is never less than or equal to 5, so this code never goes. If in a do while loop, it executes once and then checks to see if it should go again. So a do while will always execute at least one time. While loop could possibly never execute because you might not have the condition. Are there any questions about the basics? I'm going to jump into the worksheet, and hopefully that might also answer some questions.
So with the very last part of like the increment operator, is that just making that makes that next statement go up one?
It makes so this makes the I go up by 1
on the next time it loops.
It could. It depends on where you put it in your code. Because you have to be very, so it goes to 1 and then it checks it.
Okay.
So like it starts at 5. It's going to do this. It's going to go to 6. And then it's going to check to see. So it would be 6 is less than 3.
Okay.
It's since it checks it at the end, it's possible that like if we had this set to say 2, 2 would be good to go at the end, but we're not checking it to the end. We raise it by 1 before we get there. So it's going to end up being 3. So 3 would be less, not less than 3. So it would only execute one time, even though you think it should possibly go more than once. So that is where sometimes we get a lot of logic errors in our code, is you exiting a loop before you think you're supposed to or after you think you're supposed to. So that's one of the things that, like, if you're getting unexpected results or even some errors, depending on like how you coded it, check to see that you are correctly exiting a loop when you mean to exit a loop. Other questions? Okay, so let's hop into this thing. Let me zoom in. Okay. Declare a Boolean variable and set it to true. And we're just going to kind of work through this step by step. So I don't specify what to call it, so I'm just going to call it like my bool and set it equal to true. Use your Boolean variable as a conditional in a while loop. So this is, again, this is the basics of setting up a while loop. We just say while, and then what is our condition? Since this is a Boolean, we can just say my bool, because it's looking to see if is it true or false. If we're using like an integer, that's when we'd say like, my int is less than something. We then go to the next line and do our curly braces, and then we put our code inside of here that we want to execute each time we go through the loop. Change the question 1 text object text inside of the loop to give the definition of an infinite loop. After the change text statement, change the Boolean variable to false inside the loop. So question 1 text.text. What is an infinite loop? A loop that never stops. Close enough. Something along that range. And if we were to stop the code right here and try this out, we would be having an infinite loop because this is always going to be true. So notice we're not getting any kind of error message. It doesn't know that this is going to occur to us. So this is why it's really super important to take the moment to make sure that your loops are correct and that we will at some point turn our loops to false. Be it, if it's a Boolean, the Boolean would eventually in some way turn to false. If it's a number, we're incrementing or decrementing it correctly. But that is it for question 1. That's it. Questions about this one? Yes, question. This is declaring a Boolean variable. So I could call this whatever I wanted. So like, it's just like an integer but rather than an integer variable, this is a Boolean variable, and Booleans only have true or false. If this was false, we would never go into here, because this would always be not true. But down here, we're setting this equal to false, so that it'll stop. So it's going to go through one time, turn to false, and then the while loop is done. We can get out of there. If we don't, it's just going to constantly go through, and it's going to lock up Unity. Now that we're getting into looping, we're definitely going to see a little bit more with bools, because it's an easy way to kind of like manipulate loops. Okay, question 2. Declare 2 integer variables, call one counter and the other one sum, and set both equal to 0. So pretty easy. Equal to 0. Sum is equal to 0. Create a while loop using the counter variable. This is pretty common with while loops, is you have some kind of counter, if we're using like a counting up and down, you usually would name it like counter because it kind of makes sense. The loop should run until the counter reaches and includes 100. This is very specific wording, because if we want it to reach and include, what do we type into here? While counter is what? Less than or equal to 100. Because until this gets to 101, it's going to keep cycling through that loop. We do want to make sure that we increment this counter. We can just do counter plus plus. And we've taken care of making sure that we never accidentally get an infinite loop. Because this, don't accidentally do, well, I guess this would never run, but, double check your signs. Double check that you are raising your counter the correct way. Questions so far? Use the sum variable to find the sum of all the numbers between 0 and 100. So we're going to be kind of working with that counter. So sum starts at 0, counter starts at 0. What could we type in here to do this? Yes?
Sum plus equals counter.
Yes. And I'm going to kind of write out on the board how to do that, like what is happening, why do we do this? The other way you could have written this, I'm going to kind of keep it commented out. You could do sum is equal to sum plus counter. Like if this makes more sense in your brain, it's saying, take what's currently being held in sum and add what's currently being held in counter and store it back into sum. These are the same pieces of code, it's just this one is a little bit shorter. So let's kind of work through this loop. And when you start getting into looping, obviously you can't do all 100, but if you are starting to get problems with your loops, I recommend getting out a piece of paper, I do this myself, and pretending you are the computer so that you can try to figure out where the disconnect is. And a lot of ways that we can just do this is just by like writing out our variables. So we have counter, and we have sum. So they both start at 0. We go through it one time, sum gets set back to 0. We raise counter by 1. We go through again, sum plus equals counter, so 0 gets changed to 1, counter gets changed to 2. We're going to go through again, so we're going to take what's currently being held in counter and add it to sum. So 1 plus 2 is what? 3. This gets raised to 3. Let's go again. 3 plus 3? 6. This gets changed to 4. This is a really great way to try to figure out what your loops are doing. Just pretend you're the computer and kind of go through and do the arithmetic yourself. Like what if we had accidentally done this? And this can be where sometimes, you know, this wouldn't be plagiarism, but you might need a second set of eyes sometimes, and that could be me, that could be your neighbor, being like, why is this loop doing what it's doing? Because what if we accidentally did sum is equal to counter? Because maybe you thought that would be the way to approach this problem. So 0, 0. Sum is equal to counter. Counter gets raised by 1. Sum equal to counter. Counter gets raised by 2. 2, 3. It would be pretty easy to see, you know, eventually why you're not getting the results that you think. Because, you know, our end result shouldn't be 100. The end result shouldn't be 100. It should be something much higher. So kind of, even if you're not doing the whole loop, you might be able to see the pattern to see if what you're getting is what you're supposed to be getting. So there's nothing wrong with having a scratch paper and trying out things. You can find a lot of problems this way. Let's see. After your while loop, change the question to text to display what the sum is. So after the while loop, so not inside of here, if we accidentally do it in here, it's just going to get changed to, you know, we don't really necessarily want to updating every single time it iterates. We will end up with the correct result, but it's just bad coding. We don't want it like constantly writing to it. It would just be in a better habit. And it works for this time. It might not work correctly in another example. So it's just a good habit to get into to make sure that you're keeping your code meant to cycle a bunch of times. And then when you're done, question 2 text dot text is equal to sum plus sum. Questions so far? I do want to test this out just to make sure. I do want to kind of mentally look to make sure I'm not going to get any infinite loops. I'm going to make sure that this is raised and that's what I'm checking. And I know that I'm supposed to be less than, and eventually I'll get above that, and that this one is correct. I know it seems kind of silly, but not to give away too much, your next exam is going to be dealing with looping, because we're learning looping this time. You don't want to have to reboot your computer in the middle of an exam. I mean, even if you're working on the D drive, these computers take a while to boot back up, and that's just missed time on an exam. So take the opportunity, like take the extra 20 seconds to make sure that you check a couple times that your loops are okay. So I get my infinite loop, and my sum is 50-50. Questions?
Wait, so is that correct?
I think so. I mean, I'm assuming it's correct. What is the sum of the numbers from 1 to 100? 50-50. A lot higher than you would think it is. So if you're getting 100, you messed up something. Other questions? No. Okay. Let's go on to question 3. Declare 2 integer variables. Call one counter and another one product. Set counter equal to 5 and product equal to 1. Create a loop using the counter variable. The loop should run until the counter decrements to 0. So this one we did the counter up. This time we're doing the counter going down, and there might be reasons why you'd want to do it this way. So we're just going to kind of practice setting up a while loop in another way. So 2 integer variables, counter, oops, let's try that again. Int counter is equal to 5, int product is equal to 1. Create a while loop using the counter variable. The loop should run until the counter decrements to 0. We want to make sure that we're not accidentally using 0 and we want to not get necessarily to 0. Maybe we do, but the whole thing is that we're going to just be multiplying the numbers together. But we don't want to include 0, because what if you take a number and multiply it by 0, what do you get? Yes, 0. So it's kind of worthless. So we want to make sure that we either stop the loop before we get to 0, or I guess if you really wanted to, you could do some if statements, but that's kind of unnecessary. We're just going to say while counter is greater than 0, not greater than or less than like we did up here, because we don't want to have it equal to that. We're just going to say product, and we can either do multiply equal counter, or if that doesn't quite make much sense in your brain, do product is equal to product times counter. Both those lines are the exact same. They end up with the same exact results. What's the other thing we need to do? Because we're going to have a problem with what we have right now. We have to make sure that our counter gets lowered by 1. Is that what I heard? Yes?
Yes.
So that we don't get stuck in our loop. Yes, question?
Out of curiosity, is there also a times and a divide
I don't
by
believe
by?
so. I've never used it. We can try it. No, it doesn't like that.
Yeah. I figured that would be exponential.
No, it doesn't like it.
Well, the more you know. After it is.
Nope. Excuse me. The last thing we need to do is change that question 3 text.text. I'm going to mentally check my code again to make sure I don't have an infinite loop before I test this out. The counter needs to go down to 0. We're going to go into it at least once, and we are decrementing it inside of our loop, so we should not get an infinite loop. So I'm going to save it and test it out. Our product is 120. Are there any questions about this one? Yes, question.
I got an error that says the left hand side of this line must be there.
It's not, you need to add product to it because we're concatenating it, not saying equal to. Anybody else? All right, let's keep on going. So now this quiz should be super easy if you were to take it again, because we pretty much we didn't get to the do whiles yet. Declare 2 integer variables, one count counter set to 1, and the other one number of loops set equal to 0. Create a while loop that runs while the counter is less than 100. Inside the while loop, create a series of if statements. Okay, so let's just kind of start at the beginning, and we'll kind of do the first part, and then we'll get into what we have to do at the end, because this one is kind of a little bit more complex with what we're doing inside the loop and to kind of practice using some if statements with some loops. So 2 integer variables. One count counter set it equal to 1, and the other one called number of loops, and set that equal to 0. Create a while loop that runs while counter is less than 100. So while counter is less than 100. So now we kind of want to pay attention, since it does get a little bit, like there's a lot going on. If you want to kind of write out, like if you see a bunch of code and you're like, man, it's a little bit complex. There's nothing wrong, again, with getting out a piece of scratch paper and trying to, writing a couple of notes to yourself. Maybe this kind of format isn't like the best, like the most readable to you. Maybe you want to kind of translate it into a way that's better legible to you and like the way your mind works. But let's just kind of start at the top and figure this out. So inside we're going to do a series of if, else if, and else statements. So we know it's not going to be a bunch of if statements. It's if, else, If the current counter is even, raise the counter by 3. So how do we know if a number is even? Did someone say it? We've done checking for even and odd before. Yes?
Modules?
Yeah, mod 2. If we do mod 2, what does an even number give us?
0.
0. So if the current counter number is an even number, what do we want to do? Counter plus 3. And this isn't exact code, this is pseudocode, but once we get to actually typing it in, it's going to go a lot faster. If the current counter is divisible by 5, raise the counter by 2. So that would just be counter mod 5 is equal to 0. Counter what did I say? By 2. Otherwise, which is our else, raise the counter by 1. Again, your notes can be kind of sloppy as long as you understand them. That's kind of the important thing. And that's not hard to code. We've kind of done this stuff before. If you encounter a number that is both divisible by 2 and 5, such as like a 10, it should raise it by 3 and stop and not move on or raise it by 5. So if we hit here, we don't want it to also do this. That's why we did the if, else, if. That takes care of that situation. If we had done if statements, it would have been if this, do this. It would then look at the next if statement and it would have done it too. But since we did if, else, it will always do this first and then it's going to stop. It's not going to do both of them like if we encounter a 10. Does that make sense? Pretty easy to set that up. If you did it in another way, because you felt more comfortable, like if, ands or ors, that's fine too, but this is the most simplistic way to do that. Each time you go through the loop, raise the number of loop variables by 1. After your while loop has finished, print the final number. So let's code this out and then we'll make sure that we add that. So if counter mod 2 is equal to 0. So if it's divisible by 2, we know that's even. Counter plus equals 3. And again, that's the same as doing counter is equal to counter plus 3. Else, if counter mod 5 is equal to 0, is it divisible by 5? Counter plus equals 2. Otherwise, else, counter plus plus. So we took care of that, but the last thing we need to do is we need to make sure that we are raising number of loops by 1. Because we're going to count how many times do we go through here. Because it's not going to be like linear. Like we're not going to go 1, 2, 3, 4. We're going to kind of, hop up in numbers. So it shouldn't be 100. If we're getting 100, we did something wrong because it's going to be less than 100 since we're not always raising it by 1. We do want to make sure that we are we're always raising the counter no matter what. So we should not get an infinite loop ever. Yes, question.
So, when do you use those percentages again?
That's mod.
Mod.
That's when you divide a number and you take the remainder. So 10 divided by 2 is 5, remainder 0. 9 divided by 2 is 4, remainder 1. So it would be 1. So we know that it wouldn't be an even number. Same thing with this. 10 mod 5 gives you 0 because it goes in 2 times with no remainder. 9 mod 5 would give you a remainder of 4. Other questions?
So it's used with division is what you're saying, or is that?
Sort of, because you divide them and then you see what the remainder of that division is. What are we up to? Okay, so I didn't quite get to here. I didn't get a chance to finish these. I don't want to, because the class is kind of over. Miss Foster talked a lot longer than she said 5 minutes. I'm like, okay. So what I'm going to do is I am going to stop here. We will pick up with this on Tuesday, as well as the lab. I would challenge yourself to see if you can do these on your own, because it's just do while loops. I think it's do while loops. Do while, and most of them are really similar to other ones. Just be very careful, especially this last one. But see if you could take a stab at these. Get the lab up and going too, because we're gonna hit the worksheet and then we're gonna hit the lab. The lab this week is going to be dealing with, let's go into it, worksheet, too many cubes, where we're going to use buttons to generate rows and columns of cubes or a random number of cubes. And there is a walkthrough if you want to go ahead and just do it, that's great. I would recommend, you should get the UI done. You need to come to class with that done. I would also suggest take the opportunity to watch this real quick. It's only 32 minutes long. The coding isn't that bad for this one. It seems like a lot to begin with. There's a really fun new concept you're going to learn. Most of this video is talking about, like half of it is just going over, I do the thing in Photoshop where I kind of go over how we're going to approach it before we actually do the coding. The coding, I think, takes like 15 minutes. So I would suggest 100% get the UIs in place. Watch this video at least once. It's going to make doing the lab a lot easier because we're going to have some fun with this one. The project this week, you probably also want to look at the project. I will push this project due date back to Friday, next Friday. And this is me telling you this so that you are aware of it, okay? Rather than having Ball Painter due Thursday the 17th, it's going to be due on the 18th at 11:59 p.m. Sound good? I didn't do that with the debug one because that one was pretty straightforward. I want to make sure that you guys have, if you want to come on Thursday with a couple questions, but you do need to approach it. I would suggest looking at it too before class, maybe taking a stab at it, even if you're just kind of get into it and you're like, okay, I got just some stuff into place. I'd recommend it. Some of it's completed for you. There is a starter project that goes with it. I would at least have a good understanding of what's going to be expected of you with this. Questions? No? Okay. So let me turn off this recording.